Alright, today we're going to do one simple calculation, and that is involving measuring something, the height of something we can't easily measure. So, before we get started, how many triangles in that picture?
3.
How many?
3.
There are 3. 2 of them are right triangles, 1 is not. We don't care about the one that is not a right triangle. So here's the scenario. That pink segment represents the height of something we can't measure. So let's say, for instance, we want to measure the height of a mountain. Okay, you got this mountain sitting here. There's the peak of the mountain. We can get up to the top of the mountain if you want to. You can take a helicopter up there, but you can't just drop a rope down and measure the height of the mountain because you can't get to that point buried at the base of the mountain. So we have to come up with some other clever way to do it. Could you take a helicopter to the top of the mountain and use an altimeter? Yeah, probably, but we're going to pretend we don't have an altimeter here. Okay. So you understand the scenario. We can use geometry to find the height of this thing that we're going to call h. Okay. So it goes something like this. I back up away from the mountain to this point, and I measure the height I measure the angle of elevation to the top of the mountain. Okay, so let's say the angle of elevation to this mountain is 21 degrees. Okay. I use some tool that measures angles. There's tons of them. We'll make them later. And then I back up. And let's suppose I back up 7 kilometers to that point. And I remeasure the angle. Is that new angle going to be bigger or smaller than 21?
Smaller.
Smaller, correct. So I measure this angle and it turns out to be 15 degrees. Those 3 measurements are something that you can easily do. And we can use those 3 measurements now to calculate the height of the mountain. Okay, this is not an easy calculation, so I'm going to go slow. One of the distances I'm going to need to talk about is this distance, which I'll call x. And again, remember, if you introduce a variable into a problem, make sure that you label it on the problem. And as I said, 3 of those two of those 3 triangles are right triangles. We can work with those. The other triangle happens to be obtuse, which we don't know how to work with yet. We will after finals week. Okay, when we come back from break, that's the first type of problem we're going to attack. Okay, so let's take a look at, let's change the color actually. Let's okay. Ooh. There we go. Let's talk about the gray triangle first. What equation can you write involving that gray triangle?
In regards to solving what?
Yes.
Okay.
Let's go. What equation can you set up in that gray triangle? No and no. Somebody else. Oh, come on, really? From the 20 to... Go ahead.
Could you do the tangents?
Keep going.
So it would be the tangent of 21 equals h over x.
Perfect. Is that solvable?
No, because it's 2 variables.
2 variables, correct. But if I can come up with another equation, I could then solve the system. How long is that?
X plus 7k.
What?
I'm so confused.
X plus 7k and like x kilometers plus 7 kilometers.
Oh, kilometers. Oh, I thought you were just introducing notes. Okay, just stop. Looking at the big triangle with the 15 degree, what equation do we get now? You raising your hand, TJ?
No.
No? Okay, you're just waving it around. Huh?
The tangent of 15 equals h over 7 plus x.
Well done. Tangent of 15 is equal to h over 7 plus x. Is that equation solvable? No, not by itself, because again, two variables. But I should be able to solve, excuse me, for h and x now because I have two variables, two unknowns. Basic law of algebra says should be solvable. Okay, so we're going to do that. And this is going to be fun. Let's use that one. Okay, so our equations are the tangent of 25 is h over x, and the
21.
sorry, 21. 21, and the tangent of 15 is h over 7 plus x. Okay, how am I going to solve that? Just like when we were solving systems for equations of lines, ideally what I'd like is each of those equations to be solved for one of the variables, then set the two things equal to each other. Elimination is not a practical method in this case. We're actually going to use substitution. So I'm going to take this top equation and solve it for h. Why h? Because it's easier. Any problems there? Multiply both sides by the denominator. Good to go. Bottom equation. Multiply both sides by the denominator. Good to go. Those parentheses are extremely important, because without the parentheses, you're only multiplying the tangent by the x, and we want to multiply the tangent by the 7 also. Early on in the problem, you might be tempted to plug in the tangent of 15 and the tangent of 21 into your calculator. Don't do that. We're going to carry this all the way through with the tangent of 21 and the tangent of 15, and then plug it in at the very end. These two equations both equal h. So what does that tell you about the two equations? They're equal. X times the tangent of 21 is equal to 7 plus x quantity times the tangent of 15. One equation, one unknown, should be solvable, right? How? What do I do next? Go, Sam.
Could you do 10 negative 1? Never mind.
No.
No, yeah.
Go.
You get the x's to both sides?
Ow.
Or
You're right. Yeah, that's the idea. Get the x's to both sides and then solve for x, right? How? What's my next step? Go.
Did you divide by x?
No.
Oh, wait, no.
No, because you got those friends. No.
Can you divide by 7 plus x?
Nope. Yes. Hold on. Algebraically speaking, yes, you could divide by 7 plus x, but it's going to make matters worse.
You multiply 7 plus x by 10, 15.
Good. Also known as? Yes, distribute. X times the tangent of 21 is equal to 7 times the tangent of 15 plus x times the tangent of 15. Janelle, what did you say to do then?
get the x's to one side.
Right. I'm going to go to the left.
Okay, so
At this point, I've gotten rid of all the weirdness, and I've just got a bunch of terms. So it's just like solving a regular equation. I'm going to take everything with an x and move it to the left, leave everything else on the right. So I get x times the tangent of 21 minus x times the tangent of 15 is equal to 7 times the tangent of 15. What next? How do I get x by itself? No. You've already seen me just rattle off weird letters. So No,
You gonna just put it in the calculator?
not yet. We will eventually. Yes?
You divide by the tangent of 15.
You could algebraically, but that would open up a whole new can of worms, which I don't think you'd like. There's an easier approach. All right, let's do a sidebar here. Simple question. What's 2x plus 3x? Why? From a pure mathematical standpoint, the way I solve this problem or simplify this problem is I factor out a GCF. Yes? Okay, good. Now what do I do? Factor out an x. Last step.
Will you divide by the tan 21 minus tan 15?
Perfect. X is equal to 7 times the tangent of 15 divided by tangent of 21 minus tangent of 15. Oh, you might be tempted. You might be saying to yourself, hey, don't these two things cancel? Do they?
No, because
No, it's
Okay, so you got a minus sign in there. Don't do that. This, however, you type into your calculator. Go. Put this in parentheses. Es muy importante.
I got one. No, I did something wrong. Very wrong. Very wrong. I don't know. I got 16.2.
It's 17.
No.
I got 16.
So I'm seeing two answers. 5.79 or 16.1.
Don't you round up?
No, you don't round 5.9 up to 16.
I don't understand. 16.
Which one's right?
16. 16.1 because it can't be shorter than the.
So here's how I'm typing it in. Parentheses, 7 times the tangent of 15. Hold on, close parentheses, divided by parentheses, tangent 21, close parentheses, because it already stuck parentheses in there for me, minus tangent of 15, close parentheses, enter 16.1. So, here's what happens. I put in a parentheses there on my own because I'd like to put the whole numerator in a parentheses. Whether I want it to or not, the calculator sticks that parentheses in there. So I have to close that parentheses. That closes off the 15. Then I need another one to close off my numerator. No, parentheses. Parentheses here, parentheses there, parentheses here, parentheses there. If you don't close parentheses, then it thinks that everything after that parenthesis is what you're taking the tangent of. Okay? Does that make sense? Try it again to make sure you can get the right answer.
I got 8.9.
Okay, great.
16.18.
So, I don't know.
Here's this year,
Got it.
1/8 and don't round.
I'm
Why would you need another parentheses in the numerator? Because I did it without and I still got the same thing.
In this case, you don't. But I just get in the habit of putting the numerator in parentheses, because if the problem looks different and I have a plus sign in the top, that's definitely going to have to be in parentheses. So if I always put the numerator in parentheses and the denominator in parentheses before I divide, I'm more likely to have fewer problems. Sam Smith.
So I got 8.9, but I put parentheses around, like what you put parentheses around, so I
told you.
I can't
Because, okay, so hold on again, let's talk about parentheses here. I need 2 here because the first one closes the 15 for what I'm taking a tangent, the other one closes the numerator. Okay, so 16.2, but if we go back to our problem, is that the height of the mountain? No, that's our distance away from the mountain. So on your calculator, take that answer and store it into X, because again, we want to use exact answers, not approximate answers. So, how do we find the height? I can do it a couple different ways. The easiest way, in my humble opinion, is to come back up here and use that puppy. Since you have the value of X stored in your calculator, you literally have to just type in X times the tangent of 21, and we get that H is equal to 6.2 what? Kilometers.
Wait, so
Is that a reasonable answer for the height of a mountain?
no,
Yes, it is. Go ahead.
it still didn't work. It's very confusing. Wait, so you put X into
Oh, you plug X into X times the tangent of 21. So like multiply X by the tangent of
that I
21.
did this, so when I said you would have the
Yeah, you should have one to close. Yeah, I got 2 at the end. Now, what can change on this problem? Well, a lot of things. For instance, maybe I don't know the distance I backed up, and I just know the distance, what we called X in that problem. Well, if I know X, it's an easy problem. That's just a right triangle trig calculation. Or maybe I know the height, maybe I know the distance I backed up, but I'm missing this angle measure. So there's a variety of different things that we can solve for. Most of the problems, however, these are called mountain problems, by the way. Most of the mountain problems are going to go just like this. You know how far you backed up, you know the 2 angle measures, find the height of this object, whatever it is. Okay? Commonly it's a mountain. It's something that you can't easily measure the height of. If you introduce variables, or I should say when you introduce variables, make sure they're noted on your picture. If you start doing a calculation involving Z, I need to know where Z is in the picture. Or Q, or H, or Y, or whatever variables you use, I don't care. Later on, we're going to start working with this triangle and simplifying the problem a little bit, working with that white triangle instead of the 2 right triangles. Okay, so it does get easier eventually. Questions? We're good? Okay. So then,